Okay, so here is our second part that is called classical forces. Okay, so what is about classical forces? Here are three very typical forces in IGCSE. Okay, the first force is called friction force. As here you can see here, as a people here using his hand to drag a Newton-meter. And the Newton-meter then connected with a block right here, just moving through on the floor. Okay, so we can say here, if the block is not sliding, we can say it is experiencing a static friction. That means it stays still on the ground. That here is a friction force, like here. Okay. But if it has a motion or it has a velocity, we can say here right now, it has a dynamic friction. Okay. So maybe in the later, when you learn about A-level lessons or about IB or AB lessons, you will get a closer understanding of what is the difference between dynamic and static. Okay, so here today, let's just talk about something about static friction, and we can consider them are just one friction force. Okay, so when you're dragging an object, you can say here they are friction force. So what will have a difference, or what's the parameters of the physics will have a difference on the friction? We said here are two reasons. One of the reasons it is because here the object is very heavy, right? It lands on the ground, and if you want to drag it, it's very, very heavy. So once it can be pulled, we can say here must be a very strong force. Okay. So here's the first reason, it's very heavy. So it can cause frictional force increases, right? And another reason is that if the ground is very maybe rough, right? We can set here the friction force also increases, right? So we can use these two parts, we can write a formula, we can set that the friction force equals to the mu times F. And here, mu means whether the ground is rough or smooth. If it is more rough, we can set that the mu increases, okay? If it is more smoother, we can say that the mu decreases, okay? Sorry, it is more smooth, we can say that mu decreases, okay? And the force means the weight or the action force on the ground, like this way, okay? So if the object is more heavy, we can say the substance has a more friction force on it, okay? So here is a friction force just about sliding. And another force is about air resistance force. So you can see in the picture, and here's a car experiencing a friction force on its head, okay? So right now we can say that here the air resistance force is very big on the car. And you can see there's some arrows on it, right? These arrows represent for the rear wind through the car, okay? So here let's also discuss about whether air resistance will change, okay? So if you think you're a parachute and right now you're taking a parachute and try to jump down, okay, and maybe here, and you can find when you doesn't open your like here you open your parachute, we can say that your speed is very fast and your friction force is increasing with your speed increasing, right? So also you can imagine that if you're sitting in your car and you put your hand outside of the window, and here, when the car moves faster, there are more wind blows on your hand, right? So we can say that velocity increases, that will make the friction force or air resistance force increases. Okay, so there is velocity increase, air resistance force increase. And secondly, we can say that if you open the parachute, okay, like here, suddenly it will become a very big area and there are more forces acted by more air on your parachute, right? So when I said that your velocity will be decreasing, right? So that is because once the area increases, the friction force will also increases, okay? So these are two reasons why there are two different friction force, okay? So here are the two reasons. So we can say that velocity and area will depend whether the air resistance increase or not. Okay? Okay, you understand here about air resistance force? Okay, so please remind that two will leading to a difference of air resistance, and static friction. Okay. So let's move into the second part. It is about weight and gravity. So what is weight? And long time ago, there's a scientist and he stand on the tower and try to throw away two balls downward to the tower. And he find maybe at that time the people is not very clever. Okay, so once he just threw down, make the two balls free fall to the ground, and he found that the two balls fall to the ground at the same time. Maybe at that time some people will think that maybe the bigger ball will jump down at the floor quickly, but in fact they just fell into the ground at the same time. Okay. So we can say that in every time or every second, the two balls are at the same height. Okay, the same height. And here is also the same height. Okay, so if they are in the same height, we can say that, oh, every time or each time, their velocity and acceleration equals to each other. Okay, so they have the same velocity and same acceleration. So if they have the same acceleration and velocity, we can say here, they are in the same speed and they have a common acceleration downwards, right? We can say that it is G, or we can say that it's gravitational field strength from the Earth. Okay. Okay, so maybe you have some question about this. So why is there a gravitational field strength? Okay, so back to the story we had just told before. We said that when it is pandemic times, a pandemic period, Newton back to his hometown and to find that here are some stories. Okay, one day he just lies down, or maybe he's reading his books under the apple tree, right? Here's an apple falls down on his head, and he suddenly has an idea about the gravitational field strength. Maybe he thinks that, oh, here the Earth have attractive force to every object on the Earth. So here is how gravitational field strengths are be discovered. Okay, so here is about gravitational field strength, how it is come from. Okay, so here is a formula that weight equals to mass times gravity. Here is weight equals to mass, and here's gravity. And we can say that mass means the object's mass. Like when you are on a scale, okay, you can find here electrical scale. You can find here is your readings about your mass, right? Maybe you're 60 kilogram, 50 kilogram, this is mass, okay? And gravity or gravitational field strength means that here is a constant number from the Earth, okay? And normally, in IGCSE, we choose 10 or 9.8. Okay, maybe depends on your task, whether the teacher wants you to choose 10 or dash 9.8. Okay, so here are some examples. Like here, a very small slide of stone is falling down, and here its mass is 1 kilogram. So we can use the formula that weight equals to mass times gravity. So here, the weight is 1 kilogram times 10 Newton per kilogram. Okay, like this way. So here is weight is 10 Newton, okay? And another example here, you can find the stone is 2 kilogram, and here is also a force acting on it. We use the formula that weight equals to mass times gravity. So 2 kilogram times 10 Newton per kilogram, that the total force is 20 Newton. And for a person, if the mass of the person is 50 kilogram, and we can say that the total force is 500 Newton. And if here is the mass of the ball, and it experiences a weight about mass times gravity, m times g, okay? So here, maybe you have a question. So, oh, teacher Mai Lin, I'm wondering that g is a constant number or not. Because some people tell me that in different places on the Earth, that g changes. Yeah, you are correct. G changes when you are in different position. Like you are in the equator, or you are near the equator, like you're in the country like Singapore, Malaysia, or like Africa, or like maybe any other countries or Indonesia. They are very close to the equator. That G is bigger near equator. This is like scientists have proved it. Okay, and G becomes smaller when you move toward maybe to the North Pole or South Pole. Okay, North Pole or South Pole. So G becomes smaller. Maybe around the equator, maybe it's about 9.9, and maybe around the North Pole and South Pole, it becomes 9.2. Okay, here are the difference between G. So here is also three examples for the astronaut. You can find the astronaut, he travels in through the space, the moon, and the Earth. Okay. When he is at the Earth, you can find the G just equals to 10. Sometimes as we just think G equals to 10 because it's very easy for us to calculate. Okay, so here we can say that the weight is 1,000 because 100 kilogram times 10 Newton per kilogram. So the unit for G is 10 Newton per kilogram or like meter per second square. Okay, it is 1,000 Newton. And here you can find if a astronaut he's standing on the moon, because if the mass is 100 kilogram and the weight here is 100 kilogram times the G Earth, and it's 1/6 of G Earth, that is G moon. Okay, it is about 160 Newton. There you can see on some video or TV that some US astronauts are landing on the moon, he can jump higher than he is on the Earth, right? So because that the G moon is like very small rather than G Earth. Okay, so here's 1/6 of G Earth. There's 106 Newton. And for the astronaut in the space, we normally think that there's no planet to give him a attractive force. So maybe here the G equals to 0. So let's say here the mass of the astronaut is 100 kilogram and G equals to 0. So total weight here equals to 0. Okay, there are the three differences between three astronauts. Okay, okay. So here we discussed about the difference between G in different places. And here we can say that another situation is that maybe you're at the bottom of the mountain, you can find your G is very big, maybe it's 9.8. And then when you climb to the top of the mountain, maybe G becomes smaller because when you get higher, that the Earth have a less attractive force on you. So your G becomes smaller. So maybe G maybe approximately equals to 9.67, maybe like this way. Okay, so here is a different position that gravity maybe will change a little bit. Okay, so please remind that in different position that may change, but in different places that mass doesn't change because mass means the matters in your body or the total amount of the matters. Okay, so just please remember this and to take the notes down. Okay, so the last part is about Hooke's law. So Hooke's law means an object under the spring, and if you use a spring to lift an object, you can find if the weight of the object becomes heavier, and you can find the spring stretches more, right? And here stretches more. And when you use the stretches length minus the original length, you can find here it stretches about x. And the second part stretches about 2x. So here the difference is between x and 2x. And also here the weight equals to mg, and here is weight equals to 2m times g, right? Equals to 2mg. Okay. So you can find the stretches length x and 2x. And here they have a ratio between the stretches length and the force downward the spring, right? So we can use this to write down a formula that the elastic force here equals to k times x. So k means the coefficient of the spring, and x means the stretches length of the spring, right? Okay, so here is the force equals to k times x. Okay, so here it is. So here is how we calculate Hooke's law. Okay, so just please try to write down the formula and try to rethink about the meaning of Hooke's law. Okay. Okay, so this is Hooke's law. Maybe that's. Oh, okay. So I have to say more about the k, the constant number k. The k just depends on the materials of the spring. It doesn't change, or just like the g, it doesn't change because k just depends on the materials. Once you just build the spring, you can say that the spring is it just has a constant k. Like the iron is very soft, so maybe the k is very small, and maybe maybe the gold is like heavy or the steel is stronger than the iron. We can say that k becomes bigger. Okay, like this way, depends on how the materials will make an effect on the elastic. Okay. Okay. So using the three formulas or using the three classical forces, please try to solve this problem, please. Okay. Okay, so let's to our question. If you doesn't finish your like your exercises, if you doesn't finish your work, you can just keep on going and try to pause the video. Okay. So here you can say the question is on there is a spring stretches by 5 centimeter when a mass of 3 kilogram is suspended from the one end, right? So here you can say that the mass is 3 kilogram and it stretches about 5 centimeter. And here this is on the earth, so we can say the G earth. And another situation is we put the spring in the moon. And here we doesn't know the mass of the object, and here we can say it's m kilogram, right? And here, to find which mass on the moon would stretch the spring by the same extension, right? So how we can calculate? We can set here, and it is m kilogram, and the G moon equals to 1/6 of G Earth, okay? So maybe here you have some questions about this. Maybe you are consider why it can be stretches or how it can be stretches, how we can calculate this, okay? So if you doesn't have ideas, you are very math about this, you can try to write down all the formulas. Okay, so this is how we can solve the physical problems. You can just try to write down all the formulas right here. So for G Earth right here, we can say that the 3 kilogram times G means the weight, right? This is G Earth, okay? And it is here is lifted by a spring. So here we can say that is 5 centimeter times K, right? So here is the first formula, okay? And the second situation, if you also want to make the spring to stretch it about 5 centimeters, you can write down the formula to 5 centimeter times K equals to M times G moon, right? So the question is you want to find what is the mass, right? Mass right here. So here we can find the two formulas equal to each other. So we can set that the left equation equals to each other. 3G Earth equals to the mass on moon equals to G moon. Okay, like this way. So here you can set that mass equals to 3G Earth over G moon. That is 3 times, sorry, here is G Earth, and here is 1/6 of G Earth, right? Okay, just delete them and is 3 times 6. It equals to 18 kilogram, right? So we can set the question of the, sorry, the answer of the question is 18 kilogram, right? Okay, so this is for this lesson. We have discussed about the classical forces, okay? So you can take some notes and try to figure out all the questions on the fly, okay? Okay, so see you next time. Bye.